Today we're going to continue on with our Ender 3 series with part 6, and it's finally time for us to address the mainboard. What's up everyone, Chris here, and yes, we are going to continue on with our Ender 3 series. In this series of videos, we've been trying to step through the process that I would take when upgrading an Ender 3 while trying to remain a low-cost 3D printer. I don't think it's necessary to spend a lot of money on upgrades to get really good print quality. And we've come to the time now where we need to address the mainboard. And the stock mainboard on the Ender 3 does vary a little bit. Nowadays you can get a 32-bit board, and I believe you can even get ones with silent steppers. But most of the older school Ender 3s are going to have the loud mainboard like the 1.1.4 that has A4988 drivers, and it has very limited amounts of memory. So here's an example of what you will see pretty commonly on the Ender 3s. Again, I said this is a 114 board. Now these do have 4988 drivers and they are pretty loud. On some of the newer boards you're going to get silent drivers. And it does quiet down the printer a lot. But also on the A4988s like these, you can see print artifacts where you won't on some of the newer drivers. But to me that's really not the biggest issue. The big issue on these boards is this chip right here. That is an Atmega 128 chip. That's 128K of memory. And that's just not enough to get the features from Marlin that you're going to want. There's a lot of advanced features out there now that can help your print quality, and you're going to want to use them when you're using a low-cost printer like this, because you can fix a lot of issues on your printer just with firmware. So by swapping out the mainboard, we're going to be able to use all the features that we want from Marlin, and we're going to get silent stepper drivers that are going to give us better print quality and quiet down the machine a lot. But now I have to make a decision. What board do we want to use? There's a ton of them out there. And probably you're thinking it's going to be something from Big Tree Tech. Well, remember, I keep stressing on we want to keep this as low cost as possible. So the board that I chose was a MakerBase MKS Robin E3D board. And there's one big reason why. I bought this board for $12. It did take me 5 weeks to get it, but that is the cheapest board with 2209s on it that I have ever seen. Now there are a few drawbacks with this board, like you have to share a part fan. Both the part fan plugs are linked together, so they're either on or off. So you're going to have to get around that. And it handles EEPROM just a bit differently. But you get the same chip, an STM32 that you would get on a Big Tree Tech board. Most of the features are here. And it doesn't cost very much. Now, as always, with boards like this, QC might be questionable, but it's a lot easier to take when they only cost $12. So that is the route I have elected to go in. And I have used one of these boards on one of my other Ender 3s for quite a while now, and I haven't had any issues. But as you know, when you buy things like this, your mileage may vary. Every board that you get might be just a little bit different than the next one. But we're going to give it our best try. So let's jump into this upgrade, check this board out, then we'll get it installed. So here's the board we're working with here. This is an STM32 chip. Just like on a lot of the other boards, it is a 103 RCT6, 72 MHz. For the heated bed, you get an HY343D MOSFET. For the hot end, you get an HY143D. It does come with 2209 drivers. Sensorless homing is built in. You do have diag pins here that you can control it with. Just cap those. If you'd like to use sensorless homing, leave them off if not. You can switch USB or direct in power if you want to power it USB. There's a jumper port right there. It does have a CH340 serial chip like a lot of other boards do. You have ports for NeoPixels, BL Touch, filament runout sensor. There's 2 pins there. You have an LCD port for the stock CR10 style or Ender 3 screen, so EXP3 is what I like to call it. But you also have EXP1 and 2 if you'd like to use a 2004 or the 12864 screen. You have some AUX 1 pins, so you have some stuff to play with here. You could hook up your TFT screen if you want to. You do have a couple of constant 12 or 24 volt pins over here. Power in, of course. And then you have another set of constant pins right here. So on the Ender 3, the hot end fan goes on these lugs, but now you can pick whichever way you want it to go. You can put your hot end here, or you could do JST and put it over here. On the part fan, it would be nice if you could control these independently, but you cannot. These two are linked together and they are both controlled by G-code, but they're going to do the same thing. So if you put your controller fan on here, you might want to rethink that, maybe move it to the constant pins. That's up to you, because it's only going to work when the part fan is going to be on. And then your standard end stops and thermistors. This one does have emulated EEPROM, so all of that information is stored on the SD card, and it's important to note you do not get an SD card with this one. So you're going to have to get your own. On the back, the badging is pretty good, it's pretty self-explanatory. The PCB is 4 layers thick. You do get a set of cap jumpers, so that you can use them for your diag pins if you need to, and a set of heat sinks, which I will put on all these 2209s right now. I also forgot to mention you do get 2 Z plugs. Those are setting in parallel, but if you have 2 Z motors, that could be handy. So I've already removed the board I had in here. I'm going to say this every time we do one of these boards on these printers. Use ferrules on the end of your wires. Don't put the tinned ends that usually these printers have under those terminals. Bare wire is even better than the tinned wire, but put ferrules on, links in the description to the kit that I use. Also with these boards, you have to make a choice on your fan. On this one, you can go either way. You can either use a JST connector or ferrules. Stock, the Ender 3 just comes with wires, so it's easier to put ferrules on it, in my opinion. So that's the config that I'm going to go with for the hot end fan. The part fan and the controller board fan, that plug is linked together. So when the part fan's on, that controller board fan will be on. Now that's probably not the best scenario, but these drivers built in on the board, they run pretty cool anyway. But you might want to take that into account if you're going to use this in an enclosure. You intend to print a lot of stuff that doesn't need a part fan. Just be aware of that. So before we put the board in, I like to do the power and the bed. I think it's just easier to do it when the board is out. We have the negative input on the outside, the positive on the inside. Then I'm going to go ahead and put my fan in this one. That is the constant one. Working down the board, the first one is the positive one. The one next to that, the negative. Next up, we have our heated bed. Most of the time, this doesn't matter. The polarity doesn't matter on a heated bed, but some of them have LEDs on them. Not on the Ender 3 stock bed, but some do, and if you want that to work correctly, you need to put them on the correct terminals. On this board, the first one is positive. Make sure these are tied down really good. And the one next to it is the negative. And then your hot end heater. Polarity does not matter. So there you go, there's all the tie down terminals. Now I like to install it. Remember on the Ender 3, it's just these 4 screws. Same exact mount as stock. The board is in, we'll just work our way around. Right here, we have the fans. Remember, they're both G-code controlled, but they're going to be the same time. So I'm just going to put my part fan in one of them, and then I'll put my controller fan in the other. Or you could go for these back here if you wanted to. These are always on ports. They're 12 or 24 volt, whatever you're doing. 24 for the Ender 3, of course. But you could do your controller fan over there. It's just going to run constantly. Next, right here, we have our X in stop. Then next to that one, our Y in stop. And you guessed it, next to that is our Z in stop. Next to that will be your thermistor for the bed. And then on the end down here, thermistor for your hot end. Then we can plug in our LCD cable. There's a notch on the bottom of that cable. That goes to the bottom of the plug. And we're going to plug this one over here in EXP3. But this board does have EXP1 and 2. You could use it with a 2004 or a rip-rap full 128/64 display. Now we'll move to the motor side. All the way up here, we have X, then Y. Then you have 2 Z's in parallel. Doesn't matter which one you use. I'm just going to use the first one. And then all the way down here on the end, we have E. And there we go. Install is complete. Now we will check out the firmware. Remember, these boards don't come with an SD card. So we need to figure out what's actually on it and if it's configured for the Ender 3. I'll go ahead and put the cover back on. And again, I'm just plugging it in that other part cooling fan plug. So let's boot up and see what we got. A very loud beep. And we're running Marlin 2061, so it's not that old. Everything looks to be correct. Thermistors are reporting correctly. Let's go ahead and auto home. It's nice and quiet. That's great. End stops are working. Everything is moving as expected. Let's go ahead and preheat just to make sure everything's working. Also, I want to kick on this part fan. We'll go back into temperature and just make sure they're both running. And they are. So out of the box for an Ender 3, everything looks to be configured correctly. I will jump into Pronterface real quick and connect just to take a look around. We'll do an M503. We can take a look at EEPROM. But if there's no chip, there is an SD card, but it's not loaded, you shouldn't be able to save it. But it does say stored, so maybe I missed something on that board. We need to take one more look. And just looking around at some of the Marlin configurations, it looks like this board is using flash-based EEPROM. So it's storing it on the chip memory, not on the SD card. I misspoke. So still not an actual EEPROM chip, but probably better than an SD card. And if you're happy with that 206 firmware, MakerBase does have some options out here on their GitHub if you'd like to use them, including one set up for a BL Touch or a 3D Touch sensor, and they have a firmware config for the CR10. So they have tried to help you out with a few configurations here. But we can do better than that. Unfortunately, with those configurations that MakerBase has given you, the one thing that I really want to use on this 3D printer is Linear Advance, and it's not configured in those options. Now you can probably pull down their source and tweak it and re-upload it, but we might as well just build one. This is a really close configuration to a lot of the Big Tree Tech boards, so all we have to do is grab an example, change up a few things, and then we have a brand new config we can use on our Ender 3 with our board. So that's what we're going to do now. As always, we will head to marlinfw.org and we will grab the latest download. We are at 208 of Marlin right now, so we'll grab the zip. When you get your zip, you're going to want to extract all. You can right click, hit extract all, and then you can rename it. And we are going to name ours 2.0.8. And we'll extract. Inside our 208 folder, I'm going to actually make a copy of the 2.0x folder because I like to build multiples in here. And in the copy, I'm just going to rename this one to 208 underscore Ender 3 underscore MKS underscore E3D. Then we can go into this folder. And as I said before, the easiest way to build these is with an example. And there's examples out there that are really close to this one. We just have to change a few things. So if you go into Marlin, these are the stock files that you want to use for your configuration. We're just going to grab the ones from the Marlin GitHub. If you just search for Marlin GitHub, you can head in and you go into config, and this is where you can download all the examples right here. That'll be a zip file. We can extract it. When you right click extract all, you're going to get configurations release and then the version number. You can go into config, examples, and let's go to Creality, and then Ender 3. So we've got Big Tree Tech boards, we've got the Creality boards, FiStack, and in the newest version they do have one for E3 and E3P, but I'm guessing that's probably supposed to be E3D. I wasn't even aware that they had examples for this board yet. I was just going to use the mini one, but let's go ahead and pop this one open and just see what's in here. We'll just open config.h, and just looking in the firmware, the board is listed as an E3P, and you can take a look at the boards file and try to determine what's going on here. Doesn't really matter, we can always make our own. But if you go back to the GitHub, you can go to Marlin source boards, and here's where all the boards are. So it looks like they have an E3D, we have the version 1.1, and an E3P, whatever that might be. So let's just build our own. So I'm going to go with the E3 board because it's almost exactly the same as the E3D. It just has replaceable drivers. So we're going to grab this one. We got version 1.1. And we'll just copy all 4 of these files. Keith did make this config. Thanks again, Keith. Head to downloads to our 208 folder, our MKS E3D folder, Marlin, and we're going to paste it in right here. And we'll replace the destination. Now we can head to VS Code and take a look around. We'll make sure we're in File Explorer. We're going to add folder, downloads, Marlin 208. And remember, you want to add the folder that contains the Marlin folder. That would be this one right here, the one we renamed. See, there's Marlin right there. So we're going to add this folder. We'll hit add. We'll expand Marlin, pop open configuration.h. The main thing that we're concerned with is that board name. We'll just go ahead and leave Keith's name in here. We're not going to change it that much. Serial will be the same. We'll just leave it at 1. Baud rate 115200 is fine. And the only thing different about the board name is it's not E3, it's E3D. This is the one with the integrated drivers. But if you need to know those board names, again, just like on GitHub, it's exactly the same. Pop open source, core, boards.h. They are grouped by processor, so find the processor we're using. And here's the board we're going to use. Custom name, all this stuff will be good. We're just going to leave it at default. The next thing we need to check, we need to make sure that 2209s are enabled, which they are. All the motor settings, all the steps, that should be fine. We're going to leave those default. Next thing we need to pay attention to is classic jerk. Now there's a couple different ways you can configure Marlin. You could use junction deviation, you can use jerk, S-curve acceleration, linear advance, but some of those aren't compatible with each other. On a machine like Ender 3, I like to use classic jerk and linear advance. So I'm going to take the comment off classic jerk, and I'm going to lower the jerk values for X and Y from 10 to 8. Then below that, S-curve acceleration, I'm going to comment it out. Now traditionally, S-curve acceleration and linear advance, they're not compatible with each other, so they're going to cancel each other out. Now there are new features that try to let you use them both at the same time, but we'll talk about that here in a minute. No Z probe, so we'll continue on. Next thing we need to be worried about is motor direction. Now for some reason between the E3 board and the E3D board, the one with the integrated drivers, the motor direction is swapped. So we need to swap all these around. So anything that is true becomes false. Anything that's false, you guessed it, becomes true. And that's for all 4 motors. Not sure what's different there when you have the removable drivers, but this is what makes it work. And I'll go ahead and update my filament settings. I like PLA at 215 and 60. No fan, just set it to 0. ABS for a machine like this, 250, 100, no fan. And the last thing in this file that I want to alter is the encoder direction. I like for the clockwise movements to go down in the menu. So I'm just going to reverse the whole thing. I'm going to uncomment this option, reverse encoder direction right here. That will do everything in the menu, not just the menu directions. So we should be good. Now we can go on to configuration_adv.h. Now there's not a whole lot that I'm worried about in here, but I do want to make sure linear advance is set correctly. So let's scroll on through. Baby stepping is enabled. That helps you get your first layer just right. I like to see that. So we're good there. And then we come to linear advance. Now it is enabled, but you can see this option right here, experimental S-curve. I don't know anything about it yet. It is experimental, so I'm going to comment it out because traditionally S-curve acceleration and linear advance don't work well together. This could probably be a video all in itself, but for this one, I'm just going to turn it off. Also, the linear advance setting, I like to leave it at 0, 0 because I like to set mine in the slicer G-code, in the filament section. It just makes it a little handier because it's going to be different for different types of filament. Advanced Park is enabled. That's a good thing. That helps you with the M600 command. And just scrolling through, everything else looks good. So we should be in good shape to go ahead and hit build. So back to Platform I/O. I'm going to use the MKS Robin E3 environment, and we're going to hit build. The build was successful, so we're in good shape there. I'm going to mount my SD card. I'm just going to use the one that I used on the old board on my Ender 3. I do highly suggest you format your SD card. You can just right click on it, hit format, make sure it's a FAT file system, hit start. We'll close that. And I think it's just as easy to hand copy that firmware.bin file back to File Explorer. We're going to expand the PIO folder, then build, then the one for the board or processor that you've compiled. Ours is MKS Robin E3. And your firmware.bin is right there. You can right click and then reveal in File Explorer. And then usually you'd want to use this firmware.bin file. You'd copy to the board and then load it up. On these boards, it's just a bit different. But the Marlin team is taking care of us. You're going to want this Robin_E3.bin. And I'm guessing that's because of how this board treats EEPROM. The file has to be done just a little bit differently. I'm not 100% sure on that, but it does work. So we need this file. So let's right click, copy, head to our SD card, and we'll paste. And all we do to update, we just load our SD card back on the board, and we power up. This board is really annoying when it beeps, so I put my finger over the buzzer. It's going to boot, and then it's going to start to update, and it's reading out a percentage. When it reaches 100%, it'll kick over. Here's our Ender logo, and we're on 208 of Marlin. Now it's going to tell you that there's a mismatch in EEPROM. Would you like to reset it? Yes, we will. That should pull all of the default settings, just like doing an M502, and save it with an M500. And now we're up on the newest version of Marlin, and we can use Linear Advance. So now we have Marlin all up to date. We can use all the newest features, and I will leave a link to this code in the description. If you want to play with it, you can change it up however you wish. Now we need to get in and calibrate Linear Advance. Marlin has a tool for that too. So we'll walk through those steps real quick. I do have a complete video on Linear Advance. I will leave a link to that as well. So we'll head to the Linear Advance page. This is where you can use the tool to configure it. It has all the information about it here. Again, I explained it in a different video. But it does really help your print quality, and it can help printing speeds if you get your slicer tuned correctly. So from now on, with our slicer tuning, we will be tuning towards Linear Advance. So basically we need to know what our K value is. It's going to be a lot lower on direct drive and a lot higher on Bowden. This Bowden tube isn't very long, so we should be able to get it dialed in relatively easily. So this shows you what the calibration pattern looks like and how it works. Linear Advance is best when going from a slow to fast or fast to slow movement. It's compensating the amount of filament that gets kicked out during these sudden speed changes. That's why it helps you on corners of prints and things like that, when you're changing direction really quickly. And right here is our K-factor calibration pattern generator. And most of these we can just take the default because we have an Ender 3. 175 filament, 0.4 nozzle diameter. Let's do a 210 nozzle temp, bed 60, because we're going to calibrate for PLA. Remember, you should calibrate for each filament. PETG and PLA are very common, but they are going to have different Linear Advance values. Retraction distance on our Ender 3, I'm set to about a 3. Layer height, we'll keep it at 0.2. And for the test, we don't need fans. It's just one layer. We can go ahead and bump up our bed size. The Ender 3 is actually around a 235. That'll just be sure that we have room for all the test lines. Then all of these speed settings are going to be just fine for the test. It's more about moving from slow speed to fast speed than actually printing fast. This is just for the test results. So I recommend leave them default. As well as jerk values, this is going to be the same as junction deviation. Just take the firmware defaults. That config should be good. We are configuring for Linear Advanced 1.5. It does have a different K scale, but that's the current version in Marlin. And let's just start with the standard values. We'll go from 0 to 2. That's the K factor. 2 is about as high as you want to go. But we're going to have to get more granular to get it dialed in, but this will be a good starting point. And it's going to go 0.2 millimeters at a time. So that's how it's going to work up the scale. It'll start with slower speeds at the bottom, move up to faster at the top. We don't have to worry about Z offsets or bed leveling because we're still manual over here. Everything else should be good. So let's just generate our G code and we'll download the file. The file is just going through, making a line at a time, and then it ups this K value so we can see it in our test pattern. So I'm just going to copy this G code over to the SD card. Then I'm going to preheat, load up some filament, and then we'll just kick off our test. I am assuming, again, that your printer is ready to go and you've done prints, your bed's level, all that good stuff, because this test is just going to take off. But you do some prime, and then you start your lines. You can see it'll go slow to fast to slow. So here's the first test, and here's our measurements down here. We've got 0.4, 0.8, 1.2, 1.6, and so on. We're looking for the line that is the most consistent. And we're going to have to create another test to get more granular here. I'm going to say 0.6 is the best. 0.4 is a little fat right in here. Down in 0.2, it's way too sparse in the center. And then we start to get really fat in the middle up here at 0.9. So I want to see more about 0.4 to 0.8. So we need to generate another test. But we're at a good starting point here. So back to the calibration page, I'm going to set the ending K value to 1. Because we don't need to see anything bigger than that. And I'm going to set the K factor stepping, I want to move that down to 0.1. So that should give us 10 full lines of test. So let's generate that, put it on our SD card, and run it again. And here's our more granular set. 0.6 is just a little bit fat right in here. 0.8 is a lot fatter here in the center when it's doing the fast movement. So that's probably overcompensating. I'm liking 0.6 and 0.7. I think a 0.65 is where I'm going to land. I think that's a good combination in between 6 and 7. So let's go with 0.65 for our tests. So let's create some test prints. So I actually just like to do like a 50 cube, something a little bit larger so that Linear Advanced has a chance to get ramped up. And in Prusa Slicer, you can just add a shape. You can right click, add shape, box, and let's just make it 50 all around. These usually show pretty well the effect that Linear Advanced has. And then we're going to set Linear Advanced. I like to set that in the filament settings. You can do an M900 and then enter your value. We saw on the lines it's around a 6.5, a 7, somewhere in there. I ended up liking 7 a little bit better, but that's after I ran a different test. That printout that I showed you works pretty well if you have a good eye for Linear Advanced and the line that you should be picking. You can make it as granular as you want. You just have to go in and change up the G code. But I like to run a test print. I think it makes it just a little bit easier to see. And that's a dual wall print with the seam lined up. So let me show you how to make one of those. So I am going to test this one. I'll slice it and put it on my SD card. Let's can it. And then let's just add a new shape. We'll add a box again. This time we're going to make it 100 cube. And we want no infill. We'll go to print settings. I want 2 perimeters. 0 tops, and 1 bottom. And the thing that makes this work is the seam position. We're just going to set it to rear. That'll get it lined up in the back. So we can slice it. We need to alter it a little bit, but let's go ahead and slice it. You can see that seam is right back here. With this print, you can set up the G-code so that it advances the linear advance value gradually, and you can see the difference on the side of the print. So if you go to printer settings one more time, you can go to custom G-code, and I like to do them before layer changes, but you can just throw a bunch of if statements in here. I've got a bunch prepared, and I'm just going to paste them in. But in this test, I'm going to test from 0.7 at the 50 layer height all the way to 105. Again, you can do this from 0 all the way as high as you want to go. I do have a test prepared that's just a little bit over 2. I think it went to like 2.2. But I'll show you those prints. So the first 50 layers are going to be set to 0, depending on how you have your filament G-code. If you're going to run this test, just leave this blank. You can comment it out if you want to. Just use a semicolon. But then when you slice this, it's going to advance the G-code every 50 layers. So if we go back to platter, we'll just hit slice. You can export G-code, and if you do a search on layer change, we can go down through the layers. 50 would be equal to 10, so when we get to 10, you can see it put in an M900, switching it to 0.7. I think this is just a little easier way of seeing the difference between linear advance and all the different settings. So we'll do a couple of these. We'll do our 50-50, 50 cube, and a benchy, and then we'll check them out. So let's start with some of our tests. This is the most drastic one. We went up to somewhere around a 2.2 linear advance value up at the top. This is 0 down here. But you can see how pinched the corner is on the 0 value, and then how it kind of gets smoothed out, and then it's almost non-existent. There's almost no filament up here at the top. So that's not a good condition either. And you can tell how separated the seam might get. The flatter the seam is, the more linear advance you're going to have, but you want to pick a happy medium. All of these values are way too high. But then in contrast, we have the really low side of the spectrum. Again, we have 0 down here, and then I went all the way from 0.1 to about a 0.7. Now be careful with these single wall, dual wall prints. The warping of the box can actually affect the print quality, but I like something that prints a little bit faster. You might try 3 walls, it might give you a little bit more accurate part. Maybe do it just a little bit shorter than this. Also notice I have a lot of Z-banding on these parts. I was testing multiple things while I was doing this video, including some different setups for the Z, which introduced some of this, but that will be in the next video. But anyway, this is the low side. Then I did a more granular run. So this one I actually did after I did the high setting. You can see the high setting down here on the bottom. I forgot to set it back to 0, so this was still set to 2.2. But then we started to pan out. I ran it from 0.7 all the way to 1.05 up here at the top. And I did 0.05 increments. And if you look at all of them across the board, which one has the best seam, which one has the best edge, compared to all the different measurements, I still like 0.7 best. And that's down here right at the bottom. It has the best corner, it has the best seam. There's no marks on the print. And if you look real close and get it in the right light, on the edges, you can actually see how much it pulled back when it did that linear advance movement. That's something you need to keep track of as well. So if you're tuning in, you might want to go ahead and kick off one of these prints just to see what it looks like. They can be really helpful. So here's our box print. The box print actually wasn't as impressive. Again, I have that Z banding. It wasn't as impressive as it usually is when I do linear advance. They're pretty much the same. The corners on the new print, this is the after one, this is the before, they're a little bit better, but not as drastic of a change as I usually see. And that's probably pretty common on a Bowden printer. I think the print quality overall is a little bit better, but again, we need to correct that banding issue so I can better show you the results of this. But we'll get to that. But let's take a look at the Benchy real quick. The gray is before, the blue is after. I did run out of gray. But this is a great representation of what linear advance is going to help you with. You can see on the before print right in here, all these different mismatched layers where it couldn't get the extrusion quite right. They are almost perfect on the linear advance part. Linear advance is able to help predict the extrusion that's going to be needed as it goes through these different points on the part. It helps compensate and make a better print. Same way with on the smokestack, you can compare the two. And up here in the front, there's a few inconsistencies in here where you get just a little bit fatter layers. Linear advance has taken care of that or drastically reduced it. So if you're not running linear advance, I definitely recommend you take a look at it. This could be the improvement that you need for your printed parts. So there it is, our main board upgrade on our Ender 3 is complete. And I'm getting better print quality on this build than I ever have. I'm very satisfied with that. Also, with this board and chip, we're going to have enough memory to use any of the Marlin features we want to, and a lot of those can greatly help your print quality. And some of you might not agree with the board choice that I went with, but again, I was focused mainly on cost. There's a lot of great low-cost boards out there, but none that I could find that would beat this one. And a lot of these boards have some of the same issues, especially around QC, and they use the same type of processor. So definitely look at all your choices, but I think this one will be pretty decent going forward. That's it for today. Hopefully you like this video, and I'll see you really soon on the next one.